Hello everyone. In this video, I'll talk about how to find out withdrawal astigmatism, against the astigmatism, simple myopic and hyperopic astigmatism, compound myopic and hyperopic astigmatism, and mixed astigmatism from a given equation or from a given prescription. So when the greatest refractive power will be present in the vertical meridian, then it will be considered as withdrawal astigmatism. That is, the steepest power meridian will be the vertical meridian, which is again considered as 90 degree plus minus 20. 90 degree plus 20 means 110. 90 degree minus 20 is 70 degree. So the greatest refractive power, if it exists in between 70 degree to 110 degree, it could be 70, 80, 90, 100 and 110. If the axis remains between 70 degree to 110 degree, and if it is the greatest refractive power, then that astigmatism will be considered as the withdrawal astigmatism. Okay? Again, if the greatest refractive power will be present in between 20 degree to 160 degree, okay, that is 180 degree plus minus 20. 180 degree plus 20 will be 20 degree and 180 degree minus 20 will be 160 degree. It could be 20, 10, 180, okay, or 170 and 160. If the axis remains between, if the meridian remains between 20 degree to 160 degree, okay, if the greatest refractive power will be present in those meridian, then it will be considered as against the astigmatism. Okay, that means the horizontal meridian is the steepest. Okay, in withdrawal astigmatism, the vertical meridians will be the vertical meridian, that is, which will be considered from 70 to 110 degree, will be the steepest. And in against the rule, from 20, let's take this example. Suppose this is an equation, this is in prescription. This is the plus 1 diopter spherical, minus 3 diopter cylindrical, with axis 180 degree, right? So if you put this in an optical cross, what it will be? Plus 1 will be in 180 degree, right? And plus 1 minus 3, that will be, you have to add both and you will get minus 2 in this vertical meridian, right? So as you can see, we have to always take the more minus power as the steepest power. Okay, more minus 1, whichever meridian contains the more minus or less hyperopic, okay, less plus, that will be considered as the steepest one. So here minus 2 is the more steepest and this one is present in 90 degree. This is vertical meridian. So this astigmatism, the type of astigmatism will be withdrawal astigmatism. Alright? Same example, if you change the sign, it was minus 3 diopter cylindrical before, okay, now I have changed the sign into plus. So if you change it, then let's see what happens. If you put it in a optical cross again, this one will be plus 1 and you have to add it, so it will be plus 4 diopter in the vertical meridian, plus 1 diopter in the horizontal meridian. So we have to consider the less plus as the steepest one. So in between both of these, the plus 1 is the less power, less plus power, right? Plus 1 has less plus power or more towards the myopic side, right? So as this meridian will be the steepest one, that means this one is the against the rule astigmatism. So this will be the against the rule astigmatism, right? So you can directly find out after seeing the minus cylinder axis is always around the horizontal meridian, and in against the rule astigmatism, plus cylinder axis will be around the horizontal meridian. And in case of oblique astigmatism, the greatest refractive power will be present in between 20 degree to 70 degree and in between 110 degree to 160 degree. Okay, withdrawal was from 70 to 100 degree, that won't be considered under oblique astigmatism, and again from 160 degree to 20 degree, it was against the real astigmatism. So leaving those meridians, what remains? 20 degree to 70 degree, and here 110 degree to 160 degree. Okay, so the greatest refractive power, if it present in this meridian, then it will be considered as oblique astigmatism, but the meridians has to be separated by 90 degree. Okay, both the meridian has to be separated by 90 degree. Like if one meridian will be 60 degree, then other meridian will be 150 degree. 90 plus 60, it will be 150 degree. Because oblique astigmatism is also a type of regular astigmatism. Okay, there is one more type which is called as bi-oblique astigmatism, which is similar as oblique astigmatism, but only difference is that the meridians are not separated by 90 degree. That is, it has to be present in between 20 degree to 70 degree or 110 degree to 160 degree, but the meridians are not separated by 90 degree. Okay, that means if one meridian is 60 degree, the other meridian can be 130 degree, 120 degree, like that. That is subdivided in bi-oblique astigmatism. Now, how to find out simple myopic astigmatism? So just take an example. -1 diopter spherical with +1 diopter cylindrical in a plus minus scale like this. Okay, if you consider this, just consider this as the retina. Okay, so whatever rays falls in front of the retina will be taken as minus, and the others the behind the retina will be taken as plus. Okay, so +1, +2, +3, +4. Okay, more it goes towards the back side, the plus sign will be, the magnitude or the strength of the power will be increased. And again, the more it goes in front of the retina, again the strength of the minus power will increase. Okay, so from this equation, if you put this first, let's take this -1. If you put this in this graph, -1, you have to consider from this point, from the retina, it will be considered as plano or 0. Okay, so from 0 you have to take -1. That means towards the minus side, it will go 1 diopter towards the minus side, right? So it will come here. Okay, the next is +1 diopter cylindrical. So in the next meridian, it will be +1 diopter cylindrical. So you have to consider from this point now. Okay, for spherical power, you had come from this point to here, -1, and now you have to consider from this one +1. That means you have to go towards the plus sign. Okay, towards the hyperopic side. How much? 1 diopter. So if you go from this point 1 diopter backward, then it will come here. Okay, that means this is a simple myopic astigmatism, right? Okay, then again let's see the same example. The signs are different. Simple hyperopic astigmatism. Here you can see +1 diopter spherical with -1 diopter cylindrical, 90 degree. After transposing, you will get plus minus or plano with +1 diopter cylindrical at axis 180 degree. So again, if you do the same, one point will be here, right? One foci, and then from here you have to go towards minus side. How much? 1 diopter. So from here, if you go 1 diopter backward, again it will come here. That means this one is just 1 diopter plus sign. The other point is forming in the retina, on the retina, right? So if other point is forming on the retina and one point is +1, that means this is a simple hyperopic astigmatism. Again, for next is for compound myopic astigmatism. Okay, so let's take an example again. This one, -5 diopter spherical with +3 diopter cylindrical at axis 180 degree, right? So after transposition, what will you get? -2 diopter spherical with -3 diopter cylindrical at axis 90 degree. So from this equation, you can directly say that this is a compound myopic astigmatism. That means minus power is present in all the meridian but of differing amounts, right? So if you put this equation in this scale again, then the one meridian will be in this -5 diopter, and the other meridian you have to go 3 diopter towards back. That means 1 diopter, 2 diopter, 3 diopter. Okay, so the horizontal meridian will be -5 diopter myopic and the vertical meridian will be -2 diopter myopic, right? As both the meridian will be of minus power, this astigmatism will be known as compound myopic astigmatism. Okay. Again, same way for this example, +5 diopter spherical with -2 diopter cylindrical at axis 180 degree. If you put this in the scale again, what will happen? +5 diopter meridian will be here, so this meridian will be +5 diopter. The 180 degree, that is the horizontal meridian, will be +5 diopter hyperopic, and the 90 degree meridian will be +2 diopter hyperopic. Okay, so both the power and of differing amounts, this type of astigmatism will be called this compound hyperopic astigmatism. Now for this example, +1 diopter spherical with -5 diopter cylindrical at 90 degree. So when you put in the scale, it will be -4 diopter spherical. That means -4 diopter spherical will be, one meridian will be here, right? The horizontal meridian will be of -4 diopter. Myopia will be -4 diopter myopic, right? And the 90 degree meridian, that is the vertical meridian, will be +5 diopter hyperopic. So -4 +5, it will be +1, right? So the vertical meridian will be +1 diopter hyperopic, right? So again, if you see from -4, if you go 5 diopter towards plus sign, towards hyperopic sign, 1 2 3 4 5, right? Or otherwise, if you add this, -4 +5 will be +1, so other meridian will be here, right? So one meridian is of minus power and the other meridian is of plus power. So this type of astigmatism is called as mixed astigmatism. Okay.